Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in. Okay, so first we're answering some maths and skills questions on distance time graphs. So looking at this distance time graph here, I want to find the total distance travelled by the person first. So that is, what is the final distance that this person reaches? So at the very end of the time that they were travelling, it's that distance there. So then I would just read that distance across the end of my graph. And this graph isn't really accurate enough, but it's somewhere clearly between that 95 and 100 metres there, and it's roughly 97 metres. Okay, finding the speed of a person using a distance time graph in section B. So we should know that in order to do that, I actually need to find the gradient of that section of the graph. So I am going to draw in a straight line across B, and then you need to pick 2 points. So I've picked those 2 black circles there, and I'm going to draw a little triangle between those 2 points, okay? Then what I'm going to do now is I'm going to identify the coordinates of those 2 points that I have chosen. So that final point there is 45, 60, and that initial point here is 20 and 20. Okay, now to find your gradient, you need your change in y divided by your change in x. So first things first, I need to find what is the difference in those 2 y values and what is the difference in those 2 x values. So my change in y here, well, my largest y is 60 and my smallest y is 20, so 60 minus 20 is 40. And then my change in x was that 45 minus the 20 is 25. Then all I need to do is divide my change in y by my change in x, and that gives me 1.6 meters per second. Okay, finding the speed of the person at C, well, this is a distance time graph, and at C, my line is flat or horizontal, which actually means that the person is at rest. So they're stationary and their velocity must be 0 meters per second. Okay. Now I want to find the speed of the person at 85 seconds. So I first am going to identify that actually 85 seconds I'm in section D and my graph is beginning to curve. So if I have a curved section of my graph and I'm trying to find the speed, then I need to take the tangent of the curve at that point. So I'm going to draw the tangent in there like that now, and that line there, that green line, should be 90 degrees to that 85 second point. You need to again then choose 2 points on that green line now that you are going to use to find the gradient of that green line. So I've chosen those 2 red points there, and I've drawn in my little dotted red line for the triangle. So those are at 95, 100 and 60, 55. So, okay, now to find my change in y, I have got 100 minus 55 is 45, and then to find my change in x, I've got 95 minus 60 is 35. Okay, then my gradient is my change in y over my change in x. 45 divided by 35 is 1.3 meters per second. Okay, draw a line with a person moving at a constant speed that travels the distance in the same amount of time. At what points are they in front? So first things first,
if this person is traveling at a constant speed, then this line needs to have a constant gradient. Okay, so it's going to be a straight line. And then I just need to make sure that at that final time there of 100 seconds, they have traveled that 97 meters. So my line will look something like that from 0 to that final point. And then to know where they're in front, it is there any time basically where they are below that green point, anytime when my orange line is above the blue line, that person will be in front because they have covered a higher distance in the same amount of time. Okay, now on to velocity time graphs and trying to find the acceleration this time of the person in section B. Since this is a velocity time graph, the acceleration of that person is just going to be the gradient again. So I'm drawing in that line across B and finding my 2 points and doing my little dotted triangle. And those points are 45,16 and 15,4. So again, I'm going to do my change in y. So that's that 16 minus 4 is 12. And my change in x, 45 minus 15 is 30. So my gradient is just change in y over change in x, 12 over 30, 0.4 meters per second squared, okay, because it's an acceleration. Okay, now to find the deceleration of the person in the section D, so draw a straight line in. Then I've chosen these 2 points because they're quite convenient points. I can see straight away that the coordinates of those points are 75, 40 and 95, 8. So again, going for my change in y, I have got 8 minus 40, okay, because that 8 point there comes before the 40 because that is my final minus my initial velocity. So that's minus 32, and then my change in x is 95 minus 75 is 20. Gradient, change in y over change in x gives me minus 1.6, and that minus sign is just telling me that this is a deceleration. Okay, now to find out how far the person has travelled by 75 seconds. So first we need to know, in order to find a distance from a velocity time graph, we are finding the area under the graph. Now this is obviously an odd shape up to that 75 seconds, so I'm going to split that area into shapes that I know the formula to calculate the area of. And I'm going to calculate the area of all those shapes individually and then add them all together. So let's start with the purple bit that has a height of 4 and a width of 45. So 4 times 45 is 180. Then I'm moving on to my green bit, my triangle here. So that is going to be a half times the base. Well, that's between 45 and 15. So the base is actually 30 and times the height, which that one is between kind of 4 and 16. So the height of that triangle is 12. So that's 180 as well. Then I'm going to move on to my yellow triangle here. That's a half multiplied. The base there is between 45 and 75. So that's 30. And the height is between, where are we? Between 16 and between 40 there. So that's 24. And that is 360 meters total. And then finally, my orange section there, that has a base again, similar to my yellow of 30, and it is a height of 16, so 480. Then I just need to add them all together, and that gives me a total distance of 1200 meters. Okay, now let's have a look at some explanation style questions for a distance time graph. So let's describe the motion of the person. In part A here, we've got that upwards curve, which means that the person must be accelerating. Then in part B, we have a constant gradient, which we know means the person is moving at a constant speed. At C, we have that flat line, and that flat line, remember, means that our person has come to a standstill or a stop. Then in part D, it sort of curves a little bit upwards and then sort of curves that way like that. So in that little section between C and D, our person is accelerating, but then as the curve starts to level off again, they decelerate again. Remember that the speed of on a distance time graph is all to do with the gradient. So in D, we've got that increasing gradient and then it decreases, okay, hence the acceleration and then deceleration. Find the position that the person is travelling the fastest in. I am looking for the steepest gradient here, and I think that I can see that actually in part B. Now we're going to do a similar exercise, but this time for a velocity time graph. So describing the motion of the person. Part A here, when we have that flat line, the person is going at a constant speed. Part B, a positive gradient, they are accelerating. Part C, again, we have a constant positive gradient, but this time it's slightly steeper than B. So they will be accelerating at a faster rate, a larger acceleration. And then D, I have this negative gradient now, or the velocity is decreasing. Therefore, that must be a deceleration. Okay, find the position that the person is travelling the fastest in. So the position the person is travelling the fastest in is going to be the highest y value on my graph, because remember my y values are my velocities. So that's going to be between C and D, and at that point there where that person is travelling 40 meters per second. Which person has travelled the furthest? So if each area represented a different person here, which one's travelling the furthest? Well, I need to look for which one has the largest area under their part of the graph, and that is definitely part C there for the largest area. Draw a line representing a larger acceleration in part B. Well, we know a larger acceleration would be a steeper gradient, so I draw a steeper line for part B there. And what would a curved line upwards represent? Well, if there were any curved lines on this, that would actually be a changing acceleration.
Before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
So my tips and tricks for this section are, yes, firstly, double check which motion graph you're looking at. Is it a velocity graph or is it a distance time graph? Because that will obviously make a difference as to what features therefore mean what to the person's movement. My second tip is the units of the axes, and this is just to make sure that your time is in seconds and your distance is in meters. If they put the time in hours and then ask you to do some kind of calculation, you may need to first convert that time from hours into seconds. So just be aware of that. Use different shapes to check the area under the graph. Yes, there are different ways that you can split the area under a velocity time graph if you're trying to find the distance. And if you've already split it one certain way to do your original calculation, and you'd like to check your answer, can you split it into slightly different shapes to double check your answer so that you don't repeat any of the same mistakes you might have made the first time round? Your answers should obviously check out no matter how you split up that area.